Greetings everyone, welcome back to my channel Data Sculptor. Today we are going to see few topics. These are basic topics only, but I feel these are important for people who are having experience below 3 years, and if they want to move to data related roles, and if they are having interviews in SQL, these are must questions. So these are the topics: rank and dense rank and row number, the difference between all these three, having versus where clause, union versus union all, join versus union, delete versus drop versus truncate, DDL versus DML, CTE versus temp, is null versus coalesce, outer apply versus cross apply, and char, varchar, and nvarchar difference, and intersect versus inner join. So these are some few topics, theoretical topics which will be asked in interviews. So some of them might be asked. So I thought of making this video. Hope you watch till end to gain knowledge. Now we are going to find the difference between rank, dense rank, and row number. So we have this table called sales, and you have this values for the salesperson and sales. You have, if you see, for Alice it is 500, for Bob it is 700, Charlie 500, David 800, and Eve it is 700. So now let's apply. Okay, I think we need to create the table. So yeah, so now let's apply the row number. First let's see the row number. So row number basically gives you the row number irrespective of the value. I mean, irrespective of whether the value is matching or not. So order by sales. So if you do not mention anything after sales, it by default takes in ascending order. So now if you see here, Alice, since we have given order by sales, the lowest salary will be given as 1, and 2 similarly from low to high. So even if the values are matching, it will give you two different values as row number. Okay. Um so if you see 500 and 500 is matching, then it is 1 and 2. Here Bob and Eve, 700 is matching, so it's 3 and 4, and David it is 800, it is 5. So this is how row number works. So even though the value is the same for this order by clause, even though the value is same, the row number will be incremented, it will not be showing the same value. So now let's see rank. Select star comma rank over order by sales as RN from sales. So now if you see rank, uh, rank will give you the same value. So Alice and Charlie have sales as 500, so both of them are having 1. Since there are more than one rows, since there are more than one rows having the same row number, so there are two rows having this row number as 1. So row number rank 2 will be skipped. Okay, so as 1 is repeating 2 times, rank 2 will be skipped, and here rank 3 and 3, 700 and 700 is rank 3, because 500 is there are two entries for 500, and both of them are rank 1, so 2 is missed and rank 3 is repeat, and again 4 is missed and 5. Suppose if there are three 500s, then there will be three ones, and then 3 will be skipped and rank 4 will come, and then again 5. Okay, so the number that will be skipped is the number of items that exist in this a number of items that exist with the same value. Next is dense rank. So select star comma dense underscore rank over order by sales as RN from sales. So rank and dense rank are almost similar, but here if you observe difference between rank and dense rank, in rank the value 2 is missing because it has two same values, 500 and 500 is same, and there are two entries for it, so rank 1 is shared between these two, and the rank 2 is missing, and it is going to rank 3. But if you want rank 2, then you have to use dense rank. In this, no rank will be missed irrespective of the number of values. Even if you have this 500 10 times, this rank 1 will be repeated 10 times, and then it will start with rank 2. But that is not the case for dense rank. I mean, that is not the case for rank. In dense rank, the ranks will not be skipped, and in rank, the ranks will be skipped. Okay, so this is the difference between rank and dense rank. Next, we are going to see difference between group by and having. So we have this sales table, and if you see, these are the values. So Alice, Bob, Charlie, David, Eve, and Alice. So these are the sales. So first, before seeing the difference between group by and having, we'll see what is the order of execution in T-SQL. So this is the order of execution. So first, the whatever query you write. So first, the from clause will be considered. Then the join. So from means the tables which you write. First the from with the from that, and the join with multiple tables if you want to join. Then basically the tables part, whatever you write in the query, the tables part will be taken. And once the tables data is executed, I mean once the joins and required from condition and joins are execution occurred, whatever data you get, then you'll have a then you'll filter the data using the where clause. So then the data is ready, and with the data you'll group by. So you'll use the group by. Um, so basically with the data you aggregate using the group by, and with the aggregated data, if you want to filter the aggregated data, then you'll use the having clause. So after having, when you finally get the with the having, you filter out the aggregated data. So after this, um, then you write, then you use the uh, select statement. Select means whatever data is finally obtained, you retrieve the columns out of that. And once you retrieve the required columns, whatever data you want to see, whether you want to see all the data or the distinct. So distinct. So once the data set is ready with the distinct, then you use the order by. So order by is the last, and after you use the order by, limit. Limit is nothing but top. In T-SQL it is top. So top 1, top 10, and all. So this is the order of execution. So it's not group by, it is where. Okay. So where versus having. So now as we saw, first where clause will be executed, then having clause will be executed. So where clause will be executed after the from and join. So now in this case we have the select star from sales. So select star from sales, if we run, we are getting this data, or the entire data. Now what will happen? I'll apply the where clause, where sales greater than 500. So if I apply the clause where sales greater than 500, these rows will be ignored. 3 and 6 will be ignored because these are sales greater than 500. Okay. So now only these rows are coming. Now if I want to use having, I'll use group by ones. So for this one, what I'll do, select salesperson, comma, sum of sales as sales from sales, group by salesperson having sales greater than, sorry, sum of sales greater than 500. So here what will happen is, with the data set whatever you are having, over top, on top of this data set, the sum of sales will be the sum of the sales here will be aggregated. First data aggregation will happen. So for the first data aggregation to happen, filtering will not happen, data aggregation will happen. So these 500 row records will be considered. So here what happened, this 500 is considered, right? Because we are not using the where clause, we are using the group having group by clause and having clause. So first what happened, aggregation happened. So after aggregation, then you are applying the having sum of sales greater than 500. Okay, then only one row will be ignored. So now if you see, only one row is ignored. So now if, so this is the difference between sales and I mean difference between where condition and having condition. So where condition is the filtering of the data will happen before the aggregation happens, and having runs after the aggregation is happening. Okay, suppose if I want to use here also where clause, where sales greater than 500. So then what will happen? First this filtering will happen on the data, only this data is there. After that the group by will occur. Okay, after that that group by will occur, and if you run this it will be the same. Okay, hope you understood the difference between where and having clause. So now let's see the difference between union and union all. So you have two tables, sales 2019 and sales 2020, and you have the entries Alice, Bob, Charlie, and Alice, Bob, and Eve. So let's see this. These are the values for Alice, Bob, and Charlie, and Alice, Bob, and Eve. So now what I'll do, union and union all. So select sales person, comma sales from sales 2019. Okay, and I'll do union sales 2020. So basically, where I'm using only salesperson and sales, only these two columns I'm using from both the tables. Okay, so when I do this union, so what will happen? So let's together see the data together. So when I'm doing the union, basically it is merging or combining the data of the two tables into a single table. That means six entries are there. So basically these six entries I'm trying to put it in a single table. But union, what union does is, if in these six entries, if there are any duplicates, it will remove the duplicates. Okay, so if you see here, Bob 700 is there in both the tables. Okay, so that's why in the six entries, Bob 700 value comes twice. So union removes duplicates. Okay, that's why only five entries are coming. So union removes duplicates. Now if I run the same query using union all, what is the difference? So union all, it will not remove the duplicates. Okay, it will keep the duplicates as it is. So Bob 700 will come twice. So that is the difference between union and union all. So union removes duplicates, and union all retains the duplicates. So that is the basic difference between union and union all. And union, suppose union is also used to remove the um, distinct values from a table. Suppose in the same table of 2019, say I'll add one more row, um, it's Charlie 600. So suppose I'm taking this as example. Okay, and I'll insert this row. So now what will happen if I run this sales 2019? You'll see the Charlie twice, entry twice. Say now I'll just run select salesperson comma sales from sales 2019. Okay, Alice, Bob, Charlie, and Charlie. Okay, this is coming. So now what I will do, this one, to remove the duplicates, what I will do, so basically I'll write this, and basically we all use the distinct keyword. Okay, so distinct keyword will remove the duplicates. But one more way you can do is same query, just use it in a union. Okay, so select salesperson comma sales from 2019 union, select salesperson comma sales from 2019. So when I run this query, it will remove me the duplicates. Okay, this is one more way to remove the duplicate values from the same table. Thank you. Now we are going to see the difference between join and union. So basically join means combines columns from two or more tables based on a related column, and it's basically used for fetching related data spread across multiple tables. So, and union means combining the results of two or more select queries into a single result set. So useful for combining results from similar tables or queries. So what it means join and union. So join means you're merging two tables horizontally. That means suppose if a table one, say in this example, employees and departments. So in employees you have three columns, and departments you have two columns. Suppose if I want employee ID, name, department ID, and with this together I want department name also. That means I'm horizontally merging two tables. In that use case you need to use joins. And unions means you're vertically merging two tables. So for union, as I have explained earlier, sales 2019 and sales 2020 tables. If you see salesperson and sales columns are there in 2019 and 2020. So both the columns are matching. And if you want to merge these, say these four rows and three rows, total seven rows into a single table, then you use union. So basically you are merging two tables vertically. So that is the difference between join and union. So this is the simple syntax of join. You have multiple joins. Uh, I have shared in I have shared in other video what are the different types of joins. You can see that video, but basically that is the difference. So the syntax for join is select from. So first you'll write the from employees e inner join or left join or right join or cross join, any join you can use based on your requirement on e dot employee department id. So basically when you want to merge two tables horizontally, you need to find a matching column. Okay, so in joins we use matching columns. So department id is matching, so we'll join based on the department id. E dot department id is equal to d dot department id, and I'll write star, select star. Okay, so if you see here, uh, we are combining three columns table and two columns table into one output with five columns. Okay, so one more difference between union and join is for joins, the two tables which you are joining might not be not it's not necessary that the same number of columns should be there, but when you are doing union, the two tables should be having the same columns, or if not the same columns, at least the same data types it should be there. So that means when you're doing this union, salesperson and sales, both of them are same columns, and also the data type. For salesperson, it is Alice. That means it's a varchar, and the sales is 500. That means it is an integer. So and when you're doing union between 2019 and 2020, the column ordering. So first you're doing a union. So here it is the union. This is the union script. As I told earlier, sales person, comma sales union. So here salesperson and sales. So first is the varchar column and second is the integer column. So this particular order should be maintained in the second union statement as well. Okay. If this does not, if it is not maintained, so suppose if I write sales comma salesperson, that will not work. Okay. It will not work because it is not possible to convert Alice to data type. So basically, if you are interchanging, that means you are inserting 800 into this row. I mean 800, 700, 900 into this particular row, and Alice, Bob, and Eve into this particular row, which is not possible. So even the data types should be matching for the column now, ordering. So this is the difference between join and union. Hope you understand. Now we are going to see difference between delete, drop, and truncate. So basically, the purpose of all these three commands is to delete rows in the data or in the table. So let's see delete. So first is delete. The purpose is deletes specific rows from a table, and it can be used with a where clause uh, to specify which rows to delete. Transaction safe, yes, it can be rolled back if used within a transaction. Performance slower compared to truncate for large tables as it logs for each row deletion. And the triggers can be fired when rows are deleted. Okay, so delete means suppose if you have this employees table, right? If you want to delete from employees, uh, you can delete it. At the same way, if you want to delete instead of if you run this entire command, yeah, all the rows in the table will be deleted. But if you want to delete only few rows, say where employee ID is equal to 2, only one row will be deleted, right? Suppose now, so this is the purpose of delete. And suppose if you are using this delete command in a transaction, and if the transaction fails, rollback will happen. Okay, so this is the purpose of delete. And drop means it removes a table or database schema completely. So if you use delete from employees, only the table will be present, or if only the table schema will be present, but data will not be there. But if you use drop, the entire table will be deleted. So in that table, if you want to recreate the table, you have to again run the create statement. So entire table will be deleted. So that's what enter the entire table structure will be deleted with the data inside it. And is the transaction safe? No, it is not safe. It cannot be rolled back. Okay, so performance is fast because it simply removes the schema, and triggers are not fired because the table itself is removed. So this is the syntax for drop table employees. Okay, so if you run this drop table employees, it will delete the table. uh, so there is also one more schema. So suppose if you say employees 1 2 3. Okay, so what will happen if you run this table, run this if the table employee 1 2 3 is not there, then this statement will fail because this table doesn't exist. So what we'll do in order to exclude these kind of issues, so we use if exists. So drop table if exists. So suppose if this table exists, then only it will drop, otherwise it will not drop. Okay, so irrespective whether the table exists or not, this command will always successfully run, and it will delete both the schema and the data inside it. And next is truncate. So truncate removes all the rows from a table but retains the table structure. So cannot use a where clause, it deletes all the rows. So this is the difference between delete and truncate. In delete also you can delete the entire data from the table with keeping the schema, but in delete you can use the where clause. In truncate you cannot use the where clause. And is the transaction safe? Yes, it can be rolled back if used within a transaction. And performance is faster than delete because it does not log individual row deletions, and the triggers are not fired because it does not log individual row deletions. So hope you all understood the difference between truncate, delete and drop. And truncate syntax is this one: truncate table employees. So if you run this, entire table data will be deleted but schema will stay. So if you run this, schema still exists. So schema is there but data is not there. So this is the difference between delete, drop and truncate. Now let's see the difference between DDL and DML in SQL. So DDL is data definition language and DML is data manipulation language. So both are subsets of SQL. So SQL is a structured query language. So they serve different purposes in managing and manipulating data in a database. So basically DDL is used to define or alter and manage database structures or schema objects such as tables, indexes and views. So common DDL commands include create, alter, drop and truncate. So basically whenever you use a create statement, you're trying to create a new table or a view or an index. That means you're inducing new schema into the existing into the database. And similarly alter means you're trying to add a column or drop or remove a column. Basically these kind of uh, statement you use using alter. So basically alter is used to manipulate or update the schema of a table in a database. Drop you are removing the schema, that means you are dropping the table. And truncating means you are deleting the data into the existing schema. But truncate also will come into DDL because truncate will not store logs. Okay, so basically all these four are dealing with the database structures or the schema objects directly. That's why this is called data definition language. So it will deal with the schema objects, creation or altering or dropping and truncating. And next is uh, so DDL, as explained, uh, defines and manages the structure or schema of database objects. And next is DML. So DML, what it does is data manipulation language. So data manipulation language, what it does, it deals with the data inside the existing schema. So it will not touch the schema of the table, but it will deal with the data inside. Like say if you read select statement, you are trying to select the data in the existing schema. And insert, you're inserting new rows without disturbing the schema. And update, you're updating the existing rows without disturbing the schema. And delete, you're deleting the rows without disturbing the schema. So if you see all the difference between DML and DDL, in in this DML, whatever operations you are doing, logs are getting stored. And in DDL, whatever operations you are doing, logs will not be stored. So this is the basic difference of DDL and DML. Now we are going to see the difference between CTEs and temp tables in SQL. So CTEs means common table expressions. So common table expressions and temporary tables are used to store intermediate results and make complex queries more manageable. However, they have different use cases and performance implications. So CTE is named temporary result set, that is defined within the execution scope of a select, insert, update, or delete statement. So it is particularly useful for recursive queries and for breaking down complex queries into simpler and more readable parts. So when you need to run a CTE only with select, insert, update, or delete statement. Suppose you can run this only like this. So together with the scope of select statement, you need to run. Without the select statement, if you run, it will give you an error. Okay, so you need to run with together with this select statement. And once you run, you cannot again use this CTE in the in the next execution scope, because it will run only with the single. This entire thing is a single statement. Okay, so this is CTE. So you need to mind that in CTE, whenever you have um, data set which is large, you should generally not use as a best practice. When if the data set size is small, then you use the CTE. Okay, if the data set size is large, say it's having more than 1 lakh records or 10 lakh records, you should not use CTE, because that will harm your performance. And temporary tables are tables that exist temporarily and automatically dropped when the session that created them ends. So they are useful for storing intermediate results that need to be accessed multiple times or for complex data manipulations. So I hope you understood the difference between temporary tables and CTE. CTE, if declared once, it can be used only once in that execution scope. But in temporary tables, if you once declare that create that table and insert data, you can use that temporary table until that session is getting dropped. Okay, so this is how you create a temporary table. This is in T-SQL. You use the hash, create table hash employees, and you can insert the data like this. And this employees table can be used within the same session. Okay, so here in this case, hashed in this temporary tables, you can use it to store a large amount of data. And for small amount of data, if you want, you use CT. Okay, uh, and one more difference is, so how you can understand more is CTE, whatever data you store in the CTE, it is stored in the RAM. Okay, so if your RAM stored in the RAM, so your RAM it will be maximum 4 GB, 8 GB, 16 GB, right? So it will store. And the hash tables, temporary table hash tables, this is temporary tables. This data will be stored in the hard disk. So your RAM is always be smaller than your hard disk size. So you need to select whenever you, so in your CTs you need to use less data compared to your temp tables. If you're having more data, it's better to use temp tables. If you're having less data, it is better to use CTE. So these are the key differences: scope and lifespan. So CTE exists only for the duration of a single select, insert, update, or delete statement. Temporary table exists for duration of the database session. Okay, performance. CT is generally faster for simple and recursive queries, but may not perform well with large data set. So that's why I told. So, and temporary table can handle large data sets and complex manipulations better, but with some overhead of table creation and data ingestion. So as I told, CTE you cannot use for large data sets, because it occupies the RAM, and if the RAM is less, your performance of the system will be less, small, will be decreased. And CT is ideal for recursive queries and simplifying complex queries for readability. And temporary table, useful for storing intermediate results that need to be referenced multiple times across multiple queries or transactions. So hope you understood the difference between CTE and temporary tables. Both of them are used to store intermediate results, but each of everything has its own use case. Now let's see difference between is null and coalesce. So to understand difference between is null and coalesce, let's take a table called employees, and you have some columns called employee ID, name, salary, and bonus. So basically is null has only two parameters. One is the value, the column value. If this particular column is null, the whatever is the second value, it will be considered. Okay, so if you see this query, um, if you see in this data, you have employee ID as one, John, and salary as 50,000, and bonus is null. And in the next row, salary is null. So wherever null salary is null, we are replacing it with zero. So is null will work perfectly fine here, because the salary for these two rows is null, so it is replacing it with 0. So now the next thing is, suppose if I have a condition, say if the salary is null, I want to replace it with bonus, and if the bonus is also null, I want to replace it with 0. But is null follows only, it has only two parameters. So generally what we do is we use nested is null. So employee ID comma name comma is null of salary comma again is null of if the salary, if so what will happen if the salary is null, the second parameter will be executed. So in the second parameter I'll use another is null, I'll use bonus comma 0. If the bonus is also 0, then I will then I'll return I mean if the bonus is also null, then I'll return 0. Okay, so now what will happen here, if you see, this will happen. So for the first row the salary is there, so it is returned 50,000, and the second row salary is null but bonus is there, so it is returning 10,000. And if the bonus is also in third row, bonus is also null, so it is returning 0. So instead of having, and if you have multiple columns, say now here only dealing with two columns, so that's a two is nulls, are you are keeping two nested is nulls. But if you are saying, if you have a scenario where if you want five columns or six columns to handle, then it will be a very big query. Is null you have to write multiple times. So in order to solve this, we have um, one more keyword called um, coalesce. Employee ID comma name comma coalesce, coalesce of salary comma bonus comma 0 as salary. So if I run this, it will take first column, whatever is the priority, that will be considered. If this is null, the second column will be taken. If the second column is also null, then the third column is taken, will be taken. It can have any number of parameters, that is not fixed. You can have any number of parameters. So this is the difference between is null and coalesce. So is null has only two parameters, but coalesce can have any number of parameters. Suppose here if you do not give 0, if you just say salary and bonus, and in this case what will happen, if the bonus is also null, it will return null. Okay, it will not replace anything with any null, it will not be replacing with anything. But is null, if you cannot write like this. Okay, you have to replace it with some other value. So that is the difference between is null and coalesce. Now we are going to see the difference between outer apply and cross apply. So outer apply and cross apply are basically used to join a table with a table valued function or a subquery. So here instead of using the tables, both the sides of the table. So in a join, we all know in a join, whether it's an inner join or left join or right join, we use tables. Okay, but here, there might be scenarios where you might want to use some functions which returns which takes input of a column, and if you want to use that in the join will not allow. So in those cases we need to use outer apply and cross apply. Okay, so basically the definition is it is used to join a table with a table valued function or a subquery, and they are similar to left join and inner join respectively, but they are used when you need to join with a table valued function or a subquery that returns a result set. Okay, so the table value function or subquery should return a result set, and it should take input as one of the columns from the other table. That means, so here if you see this example, you have this employees table, select star from employees, and similarly you have the projects table, select star from projects. And if you see here, if you run both the tables select statements together, you are joining basically on the department ID column. Okay, so the department ID column, suppose, so now you are using select columns from employees e cross apply. Here you're writing a subquery. In this subquery, if you see, we are writing the where condition where p dot department id is equal to e dot department id. So this e dot department id, which is the department id in the employees table, is being referred inside the subquery. So that is, in these scenarios we use cross apply. Okay, So that is the difference between cross apply and the joins. So here in this cross apply basically is used to cross apply gives a inner join result. That means the IDs which are matching on both the sides. So here, since we are joining with the department ID, so the IDs which are the department IDs which are matching in both the tables, only those results will be returned, right? So if you run this statement, this is the output you get, only 1 2 and 4. Okay, so 1 2 and 4, you're getting only 1 2 and 4 because the department ID is in the employees table, it is 10 and 20, and 40 is missing in this table, and 30 is missing in this table. So only 10 and 20 rows will be coming. And if you want to get the same if you want to use the same tables but to get a left join output, you need to use the outer apply function. Okay, so the outer apply will give you this, the same syntax, but just instead of cross apply, use outer apply. So in the outer apply, so in the row 5, Ravi, for Ravi, it is giving null project name because the department ID is not there in projects. So for Ravi, you are having the department ID as 40, and there is no 40 department ID in projects table. So that's why Ravi is giving null value. So basically, this is the difference between cross apply and outer apply.
Now we are going to see the difference between char, varchar and nvarchar columns, data types. So the first one is char. So suppose take an example, create a table with example char with the column name fixed length data and char10. So what happens in char, varchar and nvarchar is, so char, when you declare the size of the data, the output of this column will always be 10. Okay, the size of the output will always be 10. That means, so if you are inserting this data, say hello, into this table, the stored value will be hello. Hello is of 5 words, right? So still 5 more words are pending, so all remaining 5 words, it will be appended with 5 spaces. So if you see this, this is the, if you see, and this hello is stored, and here some spaces are added extra. So this is char. But if you say for varchar, you are creating this varchar table. So varchar 50 is there, but if you insert with hello, it will not store extra spaces. It will store only the required number of spaces. So here it will be dynamic. I mean, based on the input length, it will be stored. So extra spaces and all will not be added. So this is the difference, basic difference between char and varchar data type. Okay. So suppose if you run this, you will see there simple hello. So if you see simple hello is there, no spaces are added. And next is nvarchar. So nvarchar means Unicode data. So you need to insert the data in this way, and the string. Here also no extra padding will be there. But the difference between varchar and nvarchar is, suppose if you want to store data, multilingual data, say in other languages, say Hindi or in Telugu or in Tamil. So those characters will be, you need to store those data in nvarchar. So you need to declare the column type as nvarchar and need to store data in nvarchar. So choosing between this data type depends on the nature of the data you need to store and whether you need support for international characters. So use char for fixed length fields, varchar for variable length fields, and nvarchar for Unicode fields. Hope you understand the difference. Difference between intersect and inner join. So as we discussed earlier, we saw the difference between joins and union. So this is also similar. So in intersect, you use when you need to find common rows between two result sets. So this is the syntax. So select column 1 and column 2 from table 1, intersect column 1 and select column 1 and column 2 from table 2. So basically, if there are two common rows between these two tables, only those rows will be returned. Whereas in inner join, you use it when you need to combine related rows from two different tables. So as I explained earlier, joins are used to merge two tables horizontally. That means you need not have the same number of columns on both the sides of the table. So here table 1 can have 5 columns, in table 2 you can have 6 columns or less than, or 3 columns. So when you join, if there is a common column between this table 1 and table 2, and if you want combine data from table 1 and table 2, then you use the joins based on the common column. But if you say this is horizontal merging, whereas for intersect it is vertical merging. So you are joining, merging two tables. Those two tables should be having the same number of columns. The same column, the column names might not be same, but the data types should be the same. So in this case, intersect will give you the common rows between both these columns. So that is the difference between intersect and inner join.